Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 28, 2025, which was about 4 days ago. The standout result is an auto-thinking multimodal model that chooses when to reason step by step, delivering state-of-the-art results across 25 benchmarks while reducing tokens on easy tasks. The paper is titled R-4B, Incentivizing General-Purpose Auto-Thinking Capability in MLLMs via Bi-Mode Annealing and Reinforced Learning. And as we will see later, the implications for model training are quite significant. It co-trains thinking and non-thinking modes, then uses Bi-Mode policy optimization to keep both skills sharp and efficient across images and text. Also, the authors shared an official GitHub repo. You'll find a clear README with intro and key features, quick start code using transformers, MLLM deployment steps with thinking mode control, sample chat templates, links to models on Hugging Face and ModelScope, experimental highlights, an Apache 2.0 license, and citations. On Hugging Face, you'll find R-4B weights around 4.8 billion parameters, plus transformers and MLLM examples for multimodal chatting with auto, long thinking, and short non-thinking modes. So, Figure 1 shows that the auto-thinking model consistently ranks at or near the top across diverse benchmarks, which means adaptive reasoning pays off without a larger parameter budget. The grouped bars compare accuracy against non-thinking, thinking, and other auto-thinking baselines. The tallest orange bars indicate wins on MM* and Logic Vista, while competitive results appear on MMMU and Math vs. Vision. This matters because balanced thinking saves tokens on easy inputs while preserving strong reasoning on hard ones. Figure 2 shows that the model switches modes based on task difficulty, which means it writes short, direct answers for simple prompts and uses step-by-step reasoning for harder ones. Auto-thinking here means the system decides whether to enter a think block before answering. The left panels contrast a dish question with a matrix puzzle, and the right bars report trigger rates. Thinking is rare on OCR Bench, but common on Math Vista. So Table 1 quantifies the Bi-Mode Annealing dataset, which matters because balanced exposure teaches both short answers and step-by-step reasoning. The table shows counts for non-reasoning and reasoning items by topic, plus each topic's share. Math K-12 contributes the largest slice, while Chart in general also occupies sizable portions. The total spans about 16 million samples, which provides broad coverage so the model can generalize across images and text. Alright, Figure 6 shows how the training explicitly compares thinking and non-thinking responses for the same prompt, so the policy learns when each mode is useful. Bi-mode policy optimization means the system generates two equal groups, one conditioned by a thinking token and one by a non-thinking token. The policy then scores both with simple reward rules and a reference model, which yields mixed advantages. This balanced setup prevents collapsing into always thinking or never thinking. Wrapping up, two takeaways stand out. Bi-mode annealing and bi-mode policy optimization let a single model master short answers and deep reasoning, and the auto-thinking policy delivers state-of-the-art accuracy while saving tokens on easy inputs. The broader implication is content-aware inference that cuts cost without sacrificing rigor. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.